This is a video for AQA Further Pure Mathematics, Matrices, section 5.6, Finding Diagonal Matrices. We saw in the last video that if M was a square matrix and it had n independent eigenvectors, then we could express M as V, D, V inverse, where D is a diagonal matrix made up of the eigenvalues of M, and V is made up of the eigenvectors in the corresponding order. So I'm going to look at this for a particular matrix now. Again, in a previous video we looked at the matrix M, which was 2, 2, negative 1, 5, and found that it had these particular eigenvectors 2, 1 and 1, 1 with eigenvalues 3 and 4. So the fact that we can write M as being equal to V, D, V inverse means that V, which is the matrix made up of the eigenvectors, so 2, 1 in the first column and 1, 1 in the second column, means that its inverse, the inverse, swapping the leading diagonal, changing the sign on the other diagonal, and then dividing by the determinant. The determinant is 1, so this ends up as 1 over 1 multiplied by 1, negative 1, negative 1, 2. The diagonal matrix that we need, D, is made up of the eigenvalues on the leading diagonal. Now it's crucial to get the eigenvalues in the correct order, so that in this particular case, the way we've written V, then we need 3 in the first element and 4 in the second one on the diagonal, and they will be zeros. And therefore M must be equal to V, D, V inverse, which is therefore 2, 1, 1, 1, 3, 0, 0, 4, and then 1, negative 1, negative 1, 2. Now you might be thinking, well, this is a lot of faff to go to write out a matrix which is quite straightforward. However, what's important about this is once we've got the matrix written in this form, it is then very simple to calculate that matrix to any power we like. So m to the power n becomes very, very straightforward. If you consider the matrix 2, 2, negative 1, 5, and trying to calculate that, for example, let's say to the power 7, as it stands, that it will be quite difficult. However, we'll look at how this diagonalization of the matrix makes this very, very, very straightforward. So to diagonalize the matrix, form V from the eigenvectors and find its inverse. Then the diagonal matrix is formed from the corresponding eigenvalues along the leading diagonal. And then M is written in this form V, D, and then V inverse. The same process would be true if it was a 3 by 3 or indeed an n by n matrix. We take the eigenvectors, calculate the inverse of the matrix which is formed using those vectors, and then the diagonal matrix has the eigenvalues on its leading diagonal. And say that one of the main points of this is that we can then find m to the power n very easily, and it's that we'll look at in the next video.